Hi guys, Dr. Justin Southey looking at question 2 of your first semester test. This was a nice simple question. We simply asked you to sketch sine of x and cosec of x, not cos of x, as most of you did, from minus 2 pi to 2 pi on the same set of axes. So we wanted one graph. Let's draw an x-axis over there, and a little y-axis. Let's put in a 1 and a minus 1. And we want to go from minus 2 pi to 2 pi. So let's have a minus 2 pi over there. That means we've got a minus pi in the middle. We've got a pi over there. And we've got a 2 pi over here. Now, let's draw sine of x first. We know that starts at 0. Some of you made it start at 1. No, that's cos graph. So sine of x starts at 0. It goes up to 1 at pi over 2. And it comes back down to 0 at pi, and it's got another little down and back up to 2 pi, 0 at 2 pi. Now some of you drew a nice neat little line with a little arrow going off to show us that sine goes on and on forever. Yes, it does keep going on and on forever, but we're only interested in the graph from minus 2 pi to 2 pi, so you lost a half a mark if your graph went on too far. Okay, and of course it repeats on the other side. Sine is periodic, so let's draw this part of it. Some of you gave your sines very pointy edges. It's not a point, it's a nice smooth curve. Just be careful of that. I didn't take away too many marks for that. And again, make sure that it stops at minus 2 pi over here. Okay, so that was an easy mark for sine of x. A lot of you drew beautiful cos x graphs as your second one, but of course we're not looking for cos, we're looking for cosec. Now, the important thing here to remember is that cosec x is equal to 1 over sine of x. And we've already asked you to draw sine, so what you could do is just take each of those values and put 1 over them and kind of work out your cosec graph from that. Of course, when sine is equal to 0, the graph is not defined, and in fact we've got asymptotes, so at all the points when sine of x is equal to 0, there's an asymptote there on the y-axis as well, here at pi, and of course at 2 pi. When sine is equal to 1, 1 over 1 is 1, so it touches each other there, and of course as sine gets smaller and smaller, cosec gets bigger and bigger. So your cosec graph looks something like that, with its asymptotes and shooting off to positive and negative infinity depending on which side of the x-axis sine is. Some of you didn't make these touch. They must touch because of course when sine x is 1, then cosec of x is also going to be 1, and that would have got you your other mark.